Hey everyone, welcome to Code Harmony. Today we are going to solve LeetCode problem ID 1534, count good triplets. This problem has been asked in companies like Microsoft, Bloomberg, Amazon, Apple, and it is based on arrays enumeration, just counting for specific things. It is marked as easy, but the interviewer can make it a bit difficult for you just by asking you to optimize the time complexity. So in this video we are going to have a look on both the cases, brute force way of doing it, because the constraints are very less, and to optimize the code, how we can optimize it. Let's have a look on the problem statement. We are given an array of integers ARR and 3 integers A, B and C, and we need to find the number of good triplets. This is the problem, and they are saying that a triplet array of 1, value at 1, value at j, value at k are forming good triplet if they are following this following condition. And the condition is we have to pick I first, then we have to pick j, then we have to pick k. So we have to pick I, j and k in order from this array, and these 3 conditions should also be satisfied. Modulus of delta, value difference between I and j, should be less than or equal to a. J and k should be less than or equal to b, and I and k should be less than or equal to c. So just these 3 conditions are given to us on the triplet of at index I, j and k. This is just modulus, and we have to return the number of good triplets. We don't need to capture the triplets, we just have to return the how many times we are encountering those triplets. So this is the whole problem statement. If we have a look on the constraints are array length is going till 100. So n is going till 100. So that is not too big. It means that we can easily do the nesting of loops. These and the value of element in the array is going till 1000. That is also not too big. Now let's have a look on the example here. First of all, this array is given to us. Apart from that, 3 variables are given to us, and we have to count the number of triplets which are following these 3 conditions. First of all, we have to pick those 3 items in order, right? Firstly we have to pick I, then j, then k, and these 3 conditions should also be matching. Difference between the value of I and j, the modulus difference between value of I and j should be less than or equal to a, and same for j value, k value, I value and k value, right? So here this is the array given to us, and we have to pick a value I and value j and value k satisfying these 3 conditions. So how many values we can have at I? We can have n values, and that we cannot have n values because we need to skip 2 values from the rightmost side. So n minus 3 till n minus 3 less than or equal to n minus 3, n minus 1, n minus 2, this is n minus 3, so less than or equal to n minus 3. And for j we can have any value greater than I plus 1 onwards, and for k it is j plus 1 onwards. So here what I am suggesting you to do is just do the nesting of loop. In short, checking for all the possible pairs of I, j and k where j is greater than I and less than k. So here is our brute force. Brute force means using nested loops. Why we are using nested loops? Because value of n is not too big. The length of this array is not too big. It's going till 100. So first loop we are using for I, second loop we are using for j, third loop we are using for k. I'm just starting the loop I from 0 to n minus 1. I know that last 2 elements will not be the valid one, but let's just keep it for simplicity. I starting from 0, j starting from I plus 1, k starting from j plus 1. So this is a loop. Approximately n time it is going to run, approximately n time it is going to run, approximately n time the third loop is going to run. After that we have to check the condition. What are the conditions? These 3 conditions we have to check: condition 1, condition 2 and condition 3. How much time I require to check all of these conditions? Order of 1 time. These are just simple expression. So checking is order of 1 time. So in short, just multiply all of these time complexities. I am coming with order of n cube. So order of n cube is the time complexity for my brute force, where I am just writing 3 loops nestedly and checking for the condition. We are not taking any extra space here, apart from these couple of variables, right? So we used nested loops because we had to pick the items in the order. And let me just tell you that n was less than equal to 100. So this approach is going to work well, and you will be able to submit this approach on LeetCode. But if you encounter this problem in the interviews, they're definitely not going to give you the constraints like this. They might give you constraints that n value will go till 5000. In that case, this approach is not that sufficient, because beyond value of n greater than 10 to the power 3, the approach is very slow, because the graph will go something like this. Okay, so here we are done with the brute force, and brute force is going to give me this time and space, and it will be submitted successfully. But for those who are willing to optimize this problem, I'm going to explain you the optimized version of this. In the optimized code, our goal is to reduce the time from n cube to n square. It means we need to figure out a way to avoid any of one loop. Here, as per the problem statement, we have to pick elements in the order. Firstly, we have to pick I, then pick j, then pick k. If we take the items in the order, we will end up taking the nested loops. So here, what I do is, I just try to fix variable j. Let's say I have fixed j. See, I is going from 0 onwards, j is going from I plus 1 onwards, and k is going from j plus 1 onwards. At least we have to visit every single item. So let's say I just take my j value from 0 to n minus 1, right? Let's say I am fixing j, and j is going to step over every single element of array. Okay, if value of j is decided, then what will the value of k? Greater than equal to j plus 1, in the same manner that we were using in the previous brute force approach. So we have fixed the value of I, we are just picking up k according to that need. Now we need to know what will be the value of I and how we can achieve that value of I efficiently. I will show you some expression for that. Firstly, it is given to us that value of I minus value of j is less than equal to a, right? And here what I have told you to do is just fix the value of j. Value of j is fixed. Now I have j, and value of k just figure out in the same manner we were doing the brute force. So one loop for n, one loop for k, and one loop for j. We are having 2 loops, and we can't afford one more loop, otherwise we'll be having n cube time. So for I, we need to do something else. Let's say what is given to us. We are given that value of I minus value of j should be having the magnitude value less than equal to a. If I try to reduce this expression, if I try to get rid of this modulus value, if it is positive, it is less than equal to a. But there might be the chances that this internal value is giving me a negative value. Let's say minus a. That is also valid. So it can be greater than equal to minus a. Now I have reduced this expression to this. If I try to arrange it further for the value of I, it will be like this. Value of I, take the ij to the left side. If I take j to the left side, it is like this. J minus a. This value of I is greater than equal to j minus a. And if I take j to the right side, it will be like this. Value of j plus a. So here this is my expression. That if you are willing to fix value of j, and you are fixing the value of k as well. If you have j and k, then the value of I will be lying within this range. But if you notice, the value of I is also in the third expression, I minus k less than equal to c. If I try to expand that as well, I minus k less than equal to c, right? If it is I minus k less than equal to c modulus. Firstly, break down the modulus. The value of I minus k less than equal to c, n can be greater than equal to minus c. So now what is the value of I coming from this expression? I will be greater than equal to k moved to the left side, k minus c, and less than equal to value of k plus c. So this is also the range coming to I, right? If we are fixing j and if we are fixing k, if value of j and k are with us, then value of k will lie from this range. The value of I can be value of j minus a less than the value of j minus plus a, and the value of I can be greater than equal to value at k minus c and less than equal to value of k plus c. So this is the range, and so if I have to satisfy this condition 1 and 2, it means for any particular value of I, that is going to be from these two values. So just combine these two ranges. If I have to combine these two ranges, what will be the range? So value of I should be greater than equal to something, less than equal to something. Greater than equal to what? Whatever is the minimum value of these two. So minimum value of j minus a and minimum value of k minus c, right? And the value of I will be maximum of less than equal to maximum of any two value, j plus a, value at j plus a, and value at k plus c. So this is my final expression. The value of I will be greater than equal to this and less than equal to this. So when we are doing iteration using j variable, and for every j variable we are picking every single k. So using these two variables, can I figure out these values? See, a, b, c, these are constant for us. The value of j we have, the value of j we have, value of k we have. So when I am iterating for the value of j, right, this is order of n iteration, and for every j I can figure out the value of k, that is another nested n. So when we are having these two iteration in this block, I have this value, comma, I have this value, comma, I have a, b and c as well. So if we have all of these three values, can I figure out the value of I? Not really, but if somehow we do something that we are able to get how many valid I are there, how many valid I can be there, because these values are given to us, and the value of I will be minimum of these two values, maximum of these two values, and value of I in the problem statement, it's already given that value of any element in the array will go from 1000 to 0 to 1000, right? 0 to 1000. It means I need to keep track of all of these elements, how many times these values are coming in the array. For any element, the value will lie from this range, and over this array we are iterating over variable j, right? Using variable j, I am iterating over my given array, and for every value of j I am calculating j manually just by doing the iteration. And for value of k, I need to know how many values are there so far which are lying between these two ranges. Let's see, if these two ranges are there, let me mark this range as L and mark this range as R. So what is the actual range of any value in this array? The actual range is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 until 1000,999, because any value in this array will lie from less than 1000 greater than equal to 0, and my main iteration is the variable j, correct? So when I'm iterating over j, I will keep on capturing the value in the end after processing. So for every value of j, I need to find every value of k, correct? These two nested and square loop. And to get to know how many values of I are there, for that what I can do is I can utilize prefix sum on value ranges. So these are the value ranges, and j value is going from 0 to n minus 1, and for every value of j, find every value of k, do the pre-processing. After that, just capture in the prefix sum. Capture in the prefix sum array. So this is the prefix sum array. It means starting from this to this, how many elements are there. Prefix sum means for value this, for value 4, how many elements are there which are less than equal to 4, right? This is something I'm going to capture in the value ranges. So here the value of I will be from L to R. Now I need to know how many elements from the array are within this range. If I tell you that total number of element within this range 0 to R, and total number of element within this range 0 to L minus 1, so you can easily figure out L minus 1, right? What I'm trying to say is that you have prefix ranges, right? Because values will be from 0 to 1000, right? At any position, how many times value is coming which is less than this value. But for value of I just need to know how many elements exist in the array which are within this range left to right in order of one time. To figure out that in order of one time, what we can utilize is range query using prefix sum. In the prefix sum, we used to figure out the solutions like that from given range, from index I to j, how many, what is the sum of elements from I to j, right? So the similar kind of approach we are going to use here. What I need to know is how many elements which are from this range, from left to right. If somehow I am able to tell these many elements, so this range, this value is going to give me elements which are less than equal to R, and this value is going to give me elements which are less than equal to L, less than equal to L minus 1. Okay, so if I just subtract this value, this R value minus L minus 1 value, what I'm going to have is all the elements which are within this range, and this value I need to figure out in order of one time, right? See, if you are having some doubt understanding this, so I would recommend watch this section again where I'm figuring out the section like optimized solution. Just watch it again, because here I am extracting the value of I, what can be the possible value of I from the range, and I came to know that the value of I can be from this range L to R. So I just need to know how many elements are there from between value L to R. For that I am utilizing prefix sum. Prefix sum on ranges. Prefix sum approach. So here, what will be my pseudocode? For every value of j, I will iterate over j, and for k, I can directly go from j plus 1 to last value. So now at this moment I have I and I have j and k. If we have j and k, I need to know how many values of I, valid value of I can have. At this moment I need to know the value of I, and the value of I will be something like this: minimum of this value and this value. This value I can figure out, this value I can figure out, and maximum of this value and this value. So for these 4 variables I need to know, and based on that I need to figure out L and R. I have captured out L and R. For L and R, I need to know how many values are there from range L to R using our prefix sum on ranges of 1000. I have figured out L and R. So using that value, let's say till R, how many elements are there till value R minus how many elements are there till value L minus 1. So if I just subtract it, I will get the answer. After that, in my prefix, I need to update the current value. What is the current value? current value is j, right? Current value is j, but I need to know how do I enter it in the prefix sum. Let's say the range is 0, 1, 2, 3, 4, 5. This is my prefix sum and I want to update the value at I, 3. If I have to update the value of 3 in the prefix sum array, it will be updated to every single element subsequent to 3. So every single element will be updated with 3. So the value, another index idx is equal to value at j, go till 1000, less than 1 equal to 1000, prefix sum of idx plus plus. So this is like a pseudocode for us, and I will show you the code for this. Here I will be able to do it in order of n square time, order of n for j and order of n for k, and this will be done in order of 1 time. Why? Because we are having ranges around 1000 and it will go around 1000 time. So it is n into 1000, approximately order of n square time. Now I will show the code for both the approaches. First, brute force approach is going to be submitted successfully, but in case it is asked in the interview to optimize it further, we need to utilize the benefit of prefix sum and problems like range update query and range sum query like this. So you need to revise these problems from prefix sum. Let's have a look on the code now. Here in the code, first of all, I am going to show you the brute force version of it. In the brute force version, I need to know the pre-triplet having values like this. Value of at I minus j is less than equal to a, and so on. So to check that, I am going to run nested loops, 3 nested loops, to figure out the value of I, j and k, and make sure the next loop is going to start from I plus 1 and the next loop is going to start from j plus 1. In this way we are going to capture this condition and these 3 conditions, and if it is satisfied, just capture the answer. So this is n cube solution, and here this is the optimized version of it. Here I am fixing the value of j, right? I have fixed the value of j, and the k is something like the similar manner. K is in a similar fashion, and this value is satisfied. Now at this moment I just need to know the value of I, exact value of I. So for that I did some analysis and came out to know that I will be lying between this left to right, and I value with respect to j is lie between array of j minus a to array of j plus a, and with respect to k it will be from array of j minus c to array of k minus c to array of k plus c. So this is the range, and definitely I'm just going to calculate the range left value and right value. And why I'm taking this 0 and 1000? Because it's already given in the constraints that the value of this array element will be from this range, so we don't have to go outside of it. So as we know left and right, then I can utilize my prefix sum logic, right? What is a prefix sum logic? If I know all the values from all the values which are less than equal to L at a position, if I know all the values which are less than equal to R at a position, then I will be able to get all the values between L to R. This is equivalent to like range query using prefix sum. And after that this j value is iterated, and this j value should be updated to the prefix sum. See, in the prefix sum it will be updated to array of j, right? But I am not going to calculate prefix sum again and again, right? So let's say 0 1 0 1. Prefix sum of this value will be like 0 1 1 2. If I am adding at any value at this position, if I am adding 1 again at line number 51, it will be added to these 3 conditions, 51 onwards, all the values. So the same logic I am putting here. Array of k I need to insert in the prefix sum. I have to insert it in every single value onwards to array of k, right? this is something I am doing so that I will be able to get all the valid value of I in order of one time, almost order of one time, because it is 1000, right? So this is the code, and if I just test by running the optimized version, it's 100% faster. I hope you understood the approach. It's a bit tricky, but I explain it to you so that you will get to know how to tackle the follow-ups in the interviews. Thank you guys. Bye bye. In case you get any doubt, you can have a discussion in the comment section below on the Discord community. Thank you guys. Bye bye.